Okay.
So today we'll focus on the harmonic analysis exercise, the kind of a demonstration on the automotive component, that is Knuckle model. So yeah, guide me. What I should do first?
Yeah. First, you have to you have to apply the load. For that, you have to do the static analysis.
Good. So
Check
static
whether
structural analysis we should do and check whether the component is.
component is safe or not.
Hmm. So material steel. So I'm not going to change anything. I'll import the
Yeah.
component. Shit here. Location. Harmonic. Tuning fork. Static structural. Dogbone. No. Where it went now? Wrench. It should be in Ansys Advanced. Knuckle. Okay.
Yeah.
I think there's background noise. It should be
From my
uploaded.
side.
Yes. Now it is fine. Okay. So now the model is loading. Yeah, this is the one. This is bit quite complex model, but let it be. So I'll just change the unit system. Mesh default, I'll run it once. Let's see what it is going to do. See, I knew that there's a model issue. Okay, so now what I'll do is instead of 5, I'll keep it 10. And then D feature is here, 3 mm. Adaptive sizing. No, let's try. Edit mesh. Fine, no? So if I see the statistics, it's 31,000 or 19,000 elements. How much you had it in your model? How much you have?
82,000, I guess. 82,605 as a nodes. 48,000 as a elements.
20. I think on an average, 60% less than you.
Yeah.
Fine, no issues. Because it should run and it should not give me the issue. I'm just taking this mesh, okay, in consideration. So it should be displacement, no? Remote displacement. Or what did you apply?
Fixed
Force?
I had applied.
No, what is the force? Force or displacement you applied?
Force.
How
Yeah,
much
force.
value?
Height is 14,000.
14,000. It's under the elastic limit, right?
Yeah. At that point of it was
14,000 Newton. Huh?
downwards. I selected that this one, not this one. Yeah, I selected that pole and applied.
Yeah, anything is fine.
Uh,
Usually you're gonna have the washers, everything, and it is going to apply on this face only, no? Practically speaking, not on this. It is just a hole, correct? Huh?
yeah,
Agree or not?
correct. It has to, that hole has nothing to do with that hole.
So now this is done. What next? So only the deformation total I need, and then stress I need, and then let's try to have the fatigue tool. Not fatigue tool here. Which one is stress tool? Stress tool, maximum equivalent stress, init factor of safety. Fine. Okay. Run this and solve. Okay, so we solved it. Total deformation is 1.5. It is pretty more. Let's see. Deformation is like this, and then equivalent stress is 245. What is the material properties for this? Structural steel,
250.
yield
250 is a
strength, yield strength is 250 compressive.
last.
Then here tensile is 250, both the same. Okay. Ultimate is 450. In the sense, our model is pretty good, not that much, but it should have 1.5 to 2.5 factor of safety, but it is near to 1. But anyway, it is fine. Okay. So now our model is pretty good with the basic structural analysis. What next?
Yeah, next we have to extract the modes.
So for that, I need to do the model analysis for this.
Model and pre-stress.
So just link here. Once you link it, if you go back and you see here also, it will be linked. This results will be extracted to the model. Okay, shortcut. Now I think here only directly it has taken condition. Here I would like to extract 10 modes. Okay, and then everything is fine. Pre-stress, I don't think so. I don't need it here. Directly only the fixture should be taken into account. Now we'll run it with this. I just need the total deformation, total run. Okay.
You have to run the pre-stress analysis, na here.
Stress, why pre-stress?
In the sense, now if you do the.
Let us see if it is going to do the free or what. Let me see. So
Yeah,
first mode, if I run, right. So static structure it has extracted and run. It's all. Now the first mode is this. So let us extract everything. So go back here, just select everything. So from here to here, just create results. Okay, and then solve it again. And there should be an option to rename based on definition. Yeah, so this will help you to easily see the mode shape, mode 1 and the respective values. Okay, this is easy for you to understand.
Can you do it once again? Can you do it? I didn't.
Just select everything, simply right click here. There's an option called rename based on the definition. Okay, so tabular data, I can just close it. Graph, let it be here. Okay, so now let us focus on it. The first mode is this. Anyway, this is what we are looking for, right? And see the second one. So this is moving like this, not needed. Third is this one is also there. 674 is what is exactly is our requirement. Even if I see this one, mode 1, this is moving like this. It won't happen practically like this. This we have only the downwards force, correct? So now mode 3 is practical and as per the requirement. And if I see other modes, these are not. So somewhere here I could see this is the natural frequency for me. Agree? 674.13, right?
Yeah.
Okay, so what next? Once you run the model analysis to do the harmonic analysis, what should you do?
I have to note down the frequency and then I have to run the harmonic analysis from by drawing down the harmonic. Yeah, here.
Harmonic. What are the settings?
Then I have to input the frequency range in analysis setting, minimum and maximum.
What is the value here?
Minimum you can put around
674 here.
590.
Don't too much it is. It is 674 in the sense minimum I would like to take it as 660. Okay, only 10 hertz lesser than this. Maximum how much you want to keep?
You can keep 690.
Okay,
700.
690 would be good. Okay, how many you want to extract? 60. Okay, 60 and every 1 hertz I would like to have it. Then it is too much. So what I'll do is 674 is there. Here I would like to take it 670. Okay, and here it is 674 in this one, 680. So now
shall we use this option, the cluster results?
Yeah, that also will do it. So that will also help here. What we'll do, we'll extract 20, and in that we will use the cluster. Yes, and how many you want there exactly where we have the peak? Let's have it 5. Okay. So this is what the definition we have it. What next you should define? What about the pre-stress?
Boundary conditions.
You want to define anything here?
Yeah, we have to define boundary conditions.
Model environment model. I would like to take the free stress environment structural. Okay. And then if you take that, do we need to define the fixture? Load.
I didn't write it, but still it is showing the question mark. I don't know why it is showing.
Let us try. Then I should have here the stress, and then I should also want to extract the where is it, frequency response. What I would like to deformation along geometry is this. So direction is y. Change it here. Okay. Now still I could see
we didn't define the damping coefficient.
I'll do that. Just a minute. Here. If I keep none, then can I able to define? Yeah, no issues. Now here I would like to add the damping constant 0.02. Okay, 3 is also fine. 3%. Okay. Now I need to define the force on this. 1 Newton is fine, or else we'll just take the same, the 14. Okay, so direction is downwards. Apply geometry, this one. No? Okay, everything is fine. So now I'll
this one constraint we have to give, otherwise does it solve?
Yeah, I didn't extract the free stress condition in the sense we should define it. Okay, fixture, this, these, and this I should uncheck. Okay, apply, done. Just solve. Once you get the results, first and foremost thing we should do is save it. Let's see. First, whether it is going to run or not, I need to see, because my system have some issues now. I crashed my graphics card last time. 1,50,000 graphics card gone. Yeah, so now could see. So when it comes to clustering, so exactly here it is 2.6, right? The highest is 2.615, right? And then what was our this one? 274.13 was the peak. So this is our resonative frequency. There only could see 274 and 275 only. Okay, 274 it is. I think if we extracted one more, then it will give the peak. So it is exactly lying between 275 and 276. Correct? So if you one could see, the clustering is also properly done here. It tries to give us from here 678 to 680 directly jump. Okay, here it is trying to extract only few. 675 to 676. 673 to 674 it is missed because it is not needed here. It tries to extract 2 points here in this. Yeah. Now with this we could see the peak amplitude is 2.6 here exactly. How do I check the exact point here, which is this point? How do you check it?
Just the table, down table, or yeah, I'll drag that down table with what will be the maximum displacement based on that.
Sorry,
not here. That those results will be there. Yeah, Yeah, can you drag it up?
No, table is not here. So for that, I should go here. Tabular data I should activate.
Oh, yeah.
So now here.
Yeah, we can see that 2.6115 is the maximum amplitude.
This one, which is the maximum here, is this.
Yeah, 11.
675.5. Correct now. So this is the peak what now. So we understood this is where we have the peak, and if you want to see the stress results, so it is exactly acting here itself. So as I said, this is what you would like to see. Like to drag it down. Stress is it exactly showing on that location? Whatever the equivalent stress you're seeing, is it exactly on whatever the frequency we would like to have it? No, right? It is showing for something else. Agree or not?
How I consider
Because it is showing here frequency last one.
680.
So I should enter the value here. What is the value?
674.5.
Hey, 675, no?
Oh, here it is that one. Previously,
I want to see this peak itself, na? 675.5. 675.5. Enter. And phase angle also would like to add here. So where is sweeping phase? This one. Switch back.
Go to that frequency for. We can take the
675, 91 point.
03.
Copy 91. 91. Okay, fine now. So resolve it, and now you could see on that particular point, this frequency, this is what it is. Okay.
Yeah.
So now how do we reduce it? So I could see exactly this kinking here. It is going to, if you this is remaining, no, for our non-linear analysis. We didn't carry forward this. Did we do it? For this we have done. I think for
snipping fit.
Not snap it, yeah, what it is. Hook. For hook we didn't do, no? Snap it also we have done. Hook only we didn't do. Okay. Now how do we, let's say if you have the automotive structure, okay, like this, you need to carry out the kind of a analysis. Then you will extract the peak. With respect to resonance, we got this peak, and it will be having the kind of a we can say working range of frequency. So 0 to 1000 hertz or 0 to 1500 hertz, it should not have a peaks. Okay. So now here we could see this 2.5 mm displacement is there, and 2.5 is too much. So they will tell us to reduce it to 0.5 mm. Okay, because it should this component, if it has only a factor of safety 1, it is not going to help us. You could see the maximum stress is too much, 5871. So what they will tell you is, on this exact particular peak, 0 to 0 to 1000 hertz, this is the peak, that is 2.6. you are seeing it here, and this particular peak should be reduced is what they will look for. So it is 2.6, it is failing. I would like to have it somewhere 2 or less than 2 is what our requirement is, they will tell. Okay. Now what you should do, you should take that model and do the kind of optimization. So you can do the topology optimization, sizing, shape, or design changes. You can contact BTViz, or you can make the manual modifications. However you want, you can proceed. But like automotive companies will go the standard process. They will go with the research team and try to do the research on it, and try to optimize the component, also try to save the mass. Okay, that is what they do.
Shall we try this increasing that damping coefficient value?
If we even increase the damping, then definitely it will decrease. The displacement will decrease.
Yeah.
That is what that is. They don't want that because practically damping they will keep 2 to 3% only. So now practically for the components damping will be fixed based on the working condition. So if you change it, it doesn't going to impact them. So we need to improvise or make the model stiff and optimize it based on the need. Okay, now answers. Uh, where is non-linear error? From where did I took that answer advance? Yeah, cool. Which one? This one, right? Was working. Knuckle one.
I'm not sure which one is.
20th one latest.
Okay.
Il cancer theme. So il burn. Can you see here? Hello? Yeah. So in this region, I think you could clearly see. Can you see this? It's going here, right?
Yeah. Then we don't have provision for.
Yeah, this side you cannot do anything.
Yeah.
So even sometimes that side also we don't have it. But just to work out now, we are just simply trying to do something. Okay, so now we need to make some design changes to improvise it, right? So I believe this structure is quite complicated to work on these all the shapes and all. So just we'll go with some advanced features. I'll try to use some features here. That the best thing is the free form. I have these many surfaces. I can drag them and improvise it. So I can do one thing. I can add the curves. Okay, one is exactly here. Okay, another one somewhere here, and one should be here, and we can even have it here one. Okay, so you can add the points. So there is option again, you can even select the polygon and you can add the point here 3, and you can drag them. Let's say here if I just click, and you can just select it and drag it outside. Let's see. So you can even drag it like this along C. This one, and similarly this. And this. With this, we are trying to increase the material there. Ultimately, this should become stiff.
Right now you are moving the curve.
If I move that curve, even it is increasing the mass. You can see that particular face is changing. Can you see that? This is modified. And now I can even directly switch to another curve once you're done with this. I can just select it and drag it out like this. Let's see, the face is also increasing, right? So this is just, I feel like a short way instead of working on the design, because it will take a lot of time to do all the modifications and uh, show the example. So better this would help us to add the material here where it is failing. Okay, this looks fine. Somewhere here also. Okay, so here I would like to slightly modify this. Like to slightly push it in. Let's see. There's a change in the design, right? So I'll simply click on OK. And now this has ultimately helped us to add the material there, right? And we can even slightly add the material, but let's see whether it is going to help us or not. Okay, so assume this is the design change we have done it. Okay, I'll just file and save as STF. The harmonic only we are dealing, right?
Yeah.
Modified. Save. So I think we need to open this workbench. Ultimately, this should improve. What do you think?
If it is uniformly increased, then we would have said that will improve, but this we are adding unevenly. I don't know what is actually.
Yeah, agreed. But in the optimization, no, the model is not like this straight smooth. If we do the shape and topology optimization, this kind of waviness will also come. Assume this material might help us. Let's think in that way and try to see how it is going to help us. So I'll just maximize it. Let me see whether I have that project open. Stop. Ansys. We are working on dynamics, right?
Yeah.
Dynamic. Which one? This one, Knuckle?
No. Yeah, that Knuckle only, but what you said, Harmonic, yeah, it's
I believe same. Let's do one thing more or less hard on it. So we'll take one more harmonic, or let's see the results of it. That will help us to see what is here, right? Yeah, we had seen it is in meters, so why I should switch to mm. It's 2.6 mm. Okay, at this region at 274 somewhat hertz. Okay, if I see the model, this is what it is, right? Now what do we do? I'll just switch back here. What do you suggest? Do you want me to create a new one or edit the same?
Yeah, it is make a new one. That is a best. Otherwise, we won't be having the previous data to verify.
Okay. So I think I do need the model, right?
Yes.
Do you know how to drag this one this side? No idea, right?
No, it won't come. Wherever that is a fixed position.
Leave it then. So this is tuning fork. I should switch to harmonic model modified. Okay. Open the model. Do you recall what are the boundary condition we had assigned last time?
Yeah. We had this bottom edge fixed, and fourth we had applied around 13,000, I think. Can you check?
Force. Let's see.
Fixed we have applied, and force we applied around 13,000, I guess so.
Let us see then. So I'll just fix it first. Okay.
Yeah.
And for the model analysis, I just need to run up to 10, more than sufficient, and extract the modes deformation total. This is the one. The force is exactly 14,000 on this face. The mesh is fine. I could see this deformation. This is not the right mode. So what do I need to do now? You should extract all first from here to here. Create mode shape results. Both same, no? So first you evaluate all. Then from here to here you select, right click and use rename based on definition. Mode 1 is repeated. You may delete one. Okay. Now you could see there's a bump, right? In the mesh also we could clearly see that. So display results, switch to wireframe. Okay, now first mode is this. Not interested. Is it the natural frequency?
No.
This one?
Yeah. Seems to be
706, right?
Yeah.
706 hertz. Now I think this is what we needed, and if I go further it is drastically increased. These are not the things which we are looking for. 706.51 hertz is what we're looking for. Next thing is we're done with the model, so I need to set up the model for Harmonic. Anyway, it is there inside, so I can even play here.
Yeah, one check. Previous model, what actually the natural frequency we got? Can we check that one? Since we had added the material, that frequency should increase. Previous one should be lesser than this. Correct?
Frequency. Okay, what is the relation between the stiffness and mass versus frequency? What is the formula for frequency?
Frequency is equal to under root of k by m.
If stiffness increases, then
frequency has increased.
Frequency should increase. Then if stiffness decreases, then
frequency should decrease.
Okay. Now 706.
Now what?
We have it.
Yeah.
Right. Let me just define the range here, and then we'll go and check it. 705. I'll take it here, and minimum is 710. 10. Okay, no issues. Let's go with that. Okay.
And you can make the clusters.
Fine. The cluster is not needed actually. If I go with 10, then I should have the clusters. Okay, then cluster of 4 points is sufficient. Now we need to define the load and also the fixture. Force on this face, apply the magnitude 14,000 and the vector reverse correct?
Hmm.
And extract deformation total and extract the frequency response deformation
In
along
Y direction.
Y. Geometry is this apply. Okay, did we apply anything here in this damping? Did we try there?
Yeah, we tried 0.003. 0.03.
Okay, let us see. We'll go and check once. Okay, quickly. That will help us. This is the one. Analysis type.
Yeah.
Harmonic is. This is what we are defining now, right?
Correct.
Yeah, I need to switch to another one. This one. Analysis types. Model it is for this one. 670 to 680 we have taken. So how much it was there? 706, huh?
706.
So frequency got increased.
Yeah. Correct.
Stiffness increased. Agree?
Correct.
So 3%. Fine. I think here it is exactly 670, and if you want to see the I need to run it again. So let's do that. Here gonna identify it as 764 hertz. 764 hertz was the natural frequency, and in this was it 764? 674. Here it is 706. It is more. Okay. Frequency more and stiffness also increased in this model.
Yeah.
Now I just need to run it. I think all are fine. So what we checked, only the damping there is fine. More last mode, or I'm looking for what? So here deformation should be exactly on 706. Let us see. And amplitude I need to cross verify, not needed now. So let us run this. Okay, solve. Now we are only concerned about the frequency response. At that peak, it should be less than 2.6 mm is what our expectation is. And now where is 706? Here.
This only is reduced tremendously.
But why the graph is different? Total deformation. No. Here the graph is different. Let me just split the screen. So if I go here, amplitude graphs looks like this. Why 670 to 680, 10 particular hertz I had taken here only.
No, here the values are in like
in negative.
Almost zero kind of. No,
it is zero
kind
itself.
of
Whatever the damping we have applied, that might be okay. Let me see here. 0.03, and here also it is same. Okay, these two are the models. So this is different here with this. Let me just cross verify everything. The first one is here. Pre-stress none, right? And then analysis settings, multi-steps no. It is linear. 670 10 particular 670 has taken. So what was our frequency here? We will just try to change it to 702. 710 will take.
Okay.
And now here the cluster I didn't took it here in this case. So let us try to remove cluster ring, so not needed. So how many 20 intervals I have extracted? So let's extract the same. Damping is 0.03, remains same. I think all fine here. And then only thing is we missed the fixture here. Apply. Okay. Anything else is missing?
No.
Just hide this. Okay. Hide this and only focus on this. Model is not needed. Static is not needed, only here. So force is here, fixture is here, and then frequency response, y-axis. So 700 to 710. I think we have implemented everything, so let's try to solve it. Yeah. You are available tomorrow?
Yeah, I'm available.
On Friday?
Friday, no.
Okay. So now you could see it was 2.61 to 1.47.
Yeah.
Got drastically reduced and our model is performing better. Correct?
Yeah. One more check can we do? What will be the change in the mass? Can we see?
Yes, we can cross verify that. Here only we can check.
Property, geometry, property.
It is mass is
14.2
kg for this model. And now here geometry
14.82 kg.
14.70
kg.
Only hardly few grams we have added. I think
Yeah.
180 grams approx, right? Yeah. So with that we could see the drastic improvement. So this is what we do actually to improvise the structures. Only slight addition of mass has drastically helped us to improve the performance. Correct?
Correct.
So with this you can save kind of millions of euros to the company and you can set up the targets. Any doubts?
Yeah. No.